D. Find the set of values for k, which the equation kx squared plus x plus k minus 1 equals 0 has real roots, one of which is positive and one of which is negative. So the first thing we do is we dissect our quadratic to realize that k is the value of a, x plus k, kx squared plus x plus k, the coefficient of x, that's always considered to be our b. So b is 1, and the k minus 1, that's our c. Now, first thing I thought was, if we're going to have a real root, b squared minus 4ac has got to be equal to 0. But since we are told one has to be positive and one has to be negative, that requires us, let me just find my notes here. I did this problem, first time I did it, came out rather I was unsatisfied with my first way of doing it. And I might have left it at home. All right. We know in order for a quadratic to have a root, we're going to want to look at the discriminant. So in this one, the b squared minus 4ac greater than 0 doesn't guarantee one positive, one negative. But regardless, we're going to want to look at the b squared minus 4ac. And in this case, b squared is going to be 1 minus 4 times a times c. We're not going to want it to be greater than 0. We're going to want it to be greater than 1. And let me show you why. We're going to be using the quadratic formula, opposite of b, plus or minus square root b squared minus 4ac. A in this one was equal to k, b was equal to 1, and c was equal to k minus 1? I'll have a quick check. Yes, k minus 1. So the discriminant part, b squared minus 4ac, I'm going to substitute in there the whole thing divided by 2a. So I'm going to now substitute in my values of a, b, and c into the quadratic formula. So the opposite of b is going to be negative 1 plus or minus square root of b squared is 1 minus 4 times a times c, whole thing divided by 2a. Now we want to guarantee one of these is positive and one is negative. What's going to be the determining factor of whether it's positive or negative? The value of k. If k comes out to be positive, provided this is all, if this comes out to be, if 1 minus 4k times k minus 1 comes out to be negative, there's no real root. So that means this piece, this crucial part here, this 1 minus 4 times k is 4k times k minus 1, this piece needs to be greater than 1 in order to make the discriminant, in order to make what's under the square root positive. Well, greater than 0 won't help, because if I come out with, if k is such that I get 1 minus something greater than 0 but less than 1, and this value of k is negative, this doesn't guarantee one positive, one negative.
No, then will that equals or is greater than 1?
Say again?
We don't want them to be equal to or greater than 1?
Well, if it equals 1, I get 0. And if k is If what I get under here comes out to be 0, then I'm only going to get 1 positive or 1 negative. Because 1 plus 0 is the same as 1 minus 0. So you've got to make this be greater than 1 to guarantee 1 positive and 1 negative. Okay, let's go with this and let's solve this now. What I'm going to do is I am going to subtract 1 from both sides, giving me negative 4k times k minus 1 is greater than 0. Why what? Why isn't? Because the value of the discriminant, which is what's the b squared minus 4ac, remember the discriminant?
Yeah.
That determines what the roots are. Since in the question, we are being told to have 1 positive and 1 negative root, that requires us to look at the values of the discriminant, not just strictly greater than 0, but greater than 1, because this 1 here, if what is here is going to be greater than 1, then we are guaranteed that this negative 1 will not eliminate and make the numerator negative.
I know, but I mean, like, isn't the, you're going to be minusing the square root of what's in...
Well, no, because if the square root, if it comes out to be greater than 1, what's the square root of something bigger than 1? It's bigger than 1. The square root of 1 is 1, right?
Yeah.
So let's say we had 1 as the discriminant. Negative 1 plus 1 cancel. That means one of my solutions is 0. And we were told in the problem we've got to have 1 positive and 1 negative, but 0 is neither positive nor negative. That's why we've got to say this discriminant must be greater than 1 to guarantee a positive and a negative root. Jackson.
If K is 1,
If k is 1,
that's fine. Right.
well, if k is 1, 0, 1 minus 0, I think no.
4K is
Let me just finish up my working, and I think you'll see where 1 is a boundary, you can get really, really close to 1, but it can't be. Let me just finish going through this here. From where we're at now, I'm telling you that the discriminant has to be greater than 1. I subtract 1 from both sides, leaving negative 4k times k minus 1 is greater than 0. What I'm going to do now, I'm going to divide both sides by negative 4 to give me k times k minus 1 is greater than 0. Once I've got this, I know k. Well, what makes this true? If k, let's just say this had equal. We know k would equal 0 or equal 1. So those are our boundaries. K's got to be greater than 0, but less than 1. Not the easiest question. That's the final answer. K's got to be greater than 0, but less than 1.
How did you go from the step before that to that side?
Come again?
How did you go from like k, bracket k minus 1 is greater than 0 to the...
Well, pick a number. Let me choose number 1.
Yeah,
1 minus 1
is 0,
times 1.
0.
Is that greater than 0? No. We can see 0 is a boundary.
Oh, okay.
I'm sorry, 1 is a boundary. Let's say I chose 2. 2 minus 1 is 1, times 2 is 2. So I can see as I'm going above 1, it's the wrong way. So I've got to be less than 1.
Yeah.
Let's use 0. 0 minus 1 is negative 1. Negative 1 times 0 is again 0. I've got to be greater than 0. So it's kind of, you can think of it as guess and check.
Yeah.
Would work fine there.